Hello, dear students. I hope you're all doing fine. Today's lecture is about the graphs of functions. It's section 2 of chapter 1. What are graphs of functions? How do we sketch the graph of a function? We will be familiar with those notions that will be used while sketching the graph of a given simple function. In general, last lecture we talked about functions, their behaviors, their properties, their domains, ranges, and so on. We know that a function is a rule that assigns from the elements of set A into exactly one element in set B. We talked about the structure of a function. In general, we said we are writing the function as y is equal to f of x. We said that x is the independent variable and y is a dependent variable because the value of y is depending on what we are giving to x. In general, we said the function is like a machine working. We talked about composition of functions and so on. Okay, the graph of a function. Of course, the graph of a function, here we have got two variables. We are working on two-dimensional space. It's not one-dimensional. When we are talking about one-dimensional space, if you wanted to sketch the graph of a function, we were just plotting numbers on the real number line. We were having a straight line, okay, one dimension. We were having the set of real numbers, okay, set of real numbers. We had origin here, 1, 2, and so on. Here we had -1, -2, and so on till it was reaching to negative infinity. If you wanted to plot any point, we were simply saying, for example, 2 is here, -half is here, and so on. That was one-dimensional space. But here, when we are sketching the graph of those functions consisting of two variables, we need two-dimensional space. In two-dimensional space, we've got two real number lines are intersecting each other. Look, this is one real number line and this one is another real number line. They're intersecting each other at the origin. Okay, that point here we have got on the real number line one dimension. 0 is the origin. Here, when those two lines are intersecting each other, that one is called the origin, and the point in the origin is 0, 0. Okay, we call this one x-axis, okay, and that one is called y-axis. So we have got here, when we were saying that, for example, x is equal to 2, simply that was the number 2. But when we are representing points on the Cartesian coordinate, let me say that one is Cartesian, or sometimes it's called plane or Cartesian coordinate, or sometimes it's called xy plane, okay, xy plane, and so on. In general, I will say Cartesian coordinate or Cartesian plane. Here, when we are defining a point, it is written in an ordered pair form. What is an ordered pair? Here we have got x is equal to 2, but when we are working on the Cartesian plane, we have got each point is represented like that as an ordered pair, okay. That one it's representing the numbers that are on the x-axis, and that why it's representing the numbers that are given on the y-axis. The intersection of those 2 points, for example, if I have got -3 and 2, okay, how do I represent that one on the Cartesian coordinate? I know that -3 is on the x-axis, so that is -3, and 2 was on the y-axis, that's 2. I will intersect those 2 points, okay, I will extend them, and the intersection of those 2 points will give me the point -3 and 2. That one is called an ordered pair. In general, we have got, when we are talking about Cartesian coordinate, we have got 4 quadrants. That one is the first quadrant, that one the second quadrant, that one the third, and that one is the fourth quadrant. Okay, in each quadrant the ordered pairs sign changes. Here we have got x and y are positive, positive. Why is it positive, positive? Because the numbers are on that quadrant of x-axis are positive, and the numbers here are also positive. Here x-axis is negative, so that is negative, and y-axis is positive. So on the second quadrant it is negative, positive. Here both x and y-axis are negative. So in the third quadrant we have got x and y are negative. Here we have got x-axis is positive and y-axis is negative. So in the fourth quadrant we have got positive, negative signs. That's about Cartesian coordinate. We are coming to the distance formula. What is distance formula? In general, distance formula. In general, when we were talking about real numbers, for example, if we had something like that, here I've got 0, 1, 2, 3, and so on. Here I've got -1, -2, -3, and so on. If I wanted to describe the distance or find the distance between, for example, -2 and 3, okay? If I wanted to find that distance, how would I find this one? That distance in one dimension. For example, we've got 2 points. I'm moving from here to there. How can I find that distance? Of course, if you want to find a point from here to there, for example, you say that is for example 13 centimeters. Here you're calculating it like that in one dimension. So how were we finding the distance between those two numbers, 3 and -2? You simply say that this is equal to, that's the distance rule, distance between a and b on the real number line is equal to b minus a. What is b? b is -2 here and a is 3 here. So I will have an absolute value of b, that's -2. I will grab this minus from the rule, put it here, and a is equal to what? 3. So -2, -3 is equal to -5. -5 in the absolute value is equal to 5. Why did I put that absolute value here? Because I'm calculating the distance between 2 points, 2 places, okay? Distance cannot be negative. That's why we are putting that absolute value in here. That is about distance in one dimension, a point to another point. How about if I have got two-dimensional space? For example, if I want to find the distance between, for example, that point, that's -2, -2, and that point, that's 2, 2, okay? I want to find that distance. If you look at here I have got 2 simple points, but here each point is representing an ordered pair. So how can I find this one? I will say that the distance, okay, I will write the formula later on here, between -2, -2, and 2, 2. That one is representing the a there. It's like this one. I'm not saying that we are using the same rule, but I'm making the difference between this one and that one. I mean like similarity between them, not difference. And that b is the ordered pair 2, 2. So the points here are given as ordered pairs. This one is only 1 point. Look, it's not 2 points. It's an ordered pair. It represents only 1 point, and that one is also another ordered pair. How do we find that distance? I have got a distance formula for Cartesian coordinate. I will say that if I have got 2 points, x1, y1, and x2, y2. Okay, I'm giving 2 points, x1, y1, x2, y2, or you can say this one is x1, y1, that one is x2, y2. It doesn't make a difference. It will still give you the same result, okay? So if I have got 2 points, I'll find the distance between this point and that point as x2 minus x1 squared plus y2 minus y1 squared. Okay, so that is the distance formula, and these are all under the square root. So how do I find the distance between this point and that point? That one is x1, y1, and that one is x2, y2. How do I find that distance? Simply using the formula. x2 minus x1. x2 is 2, minus is, I'm grabbing it from the rule, x1 is negative 2. Look, I will write this negative back in here because that is x1, okay? That negative is from the rule and x1 is negative 2. Please do not make mistakes while putting these numbers back into the places of the x's and y's. Okay, then plus, okay, I'm grabbing that plus from the rule and put it here. y2 is 2 minus, I'm grabbing it from the rule, y1. y1 is negative 2, so that one is again negative 2 squared, all under the square root. Okay, let's calculate this one. That one is equal to 2 minus 2. 2 minus minus 2 is equal to what? Is equal to 4 squared, plus this one is again 4 squared, all under the square root. 4 squared is equal to 16 plus 16, that's the square root of 32. So the distance between this point and that point is equal to what? Is equal to square root of 32. That's how we find the distance between 2 points on the Cartesian coordinate. Let's move to the first example that's given to us. The first example is example 1, 2, 1. It's giving you points p negative 2, 5, and another point that's 4 and negative 1. You're doing the same procedure as we did for this one. I think you will not need that example. I mean, it's important. Of course, you have to do it, but the solution is the same way as this one, okay? That's why I'm not doing it for you. I'll skip it, but you have to do it yourselves. Now we are coming to the graph of a function. As we have studied, the graph of a function. Now, we know what's a function. We know what's the Cartesian coordinate. We know how to plot numbers on the Cartesian coordinate. So we are coming to the graph of a function. I'll give you a very simple example, or already the example is given in the course material. It's example 1, 2, 2. Okay, says sketch the graph of the function f of x that's equal to x squared. Here, the first example is solved by plotting. As I told you, it's required from us to find f of x, the graph, sketch the graph of f of x that's equal to x squared. You're already familiar of that function. You know it's a parabola facing upwards because it's positive. But how do we sketch the graph of this one? Using plotting, okay, because here we are using plotting. Plotting is what? I'm giving values to x, will get y, and an ordered pair. So I'm giving x values, I will get y, and then from both of them I'll get xy. Of course, when you're putting numbers into that function, giving points, you have to give positive numbers, negative numbers, and zero, so that you will have a variety of points describing every corner of the function that we have got. So I will start with negative 2. I'll give negative 2 to the function that I have got, negative 1, 0, 1, and 2. Of course, you can give negative 3, negative 4, 3, 4, or other numbers, halves, whatever number you like, but I'm choosing the simple ones here. Okay, if I put negative 2 into here, what will I get? Negative 2 squared, that's equal to 4. So the ordered pair x is equal to negative 2 and the y is equal to 4. The second point, I'm putting negative 1 into here. Negative 1 squared is equal to what? Is equal to 1. Okay, so the point ordered pair x is negative 1 and y is 1. If I put 0 into here, what will I get? I will get 0, okay, because 0 squared is 0, so I will get the origin, that's 0, 0, okay. That one, if I put 1 into here, 1 squared is 1, so the ordered pair is 1 and 1. If I put 2 into there, I will get 4, so the ordered pair is 2 and 4. Now I'm coming to put those points on the Cartesian coordinate. -2 and 4, that's -2, okay, and 4, so that one will be the point that we have got, okay. That one is -2 and 4. Then I have got -1 and 1, so that one is -1 and 1. Then I have got 0 0, that is the origin, okay, so that ones are the points. Then I have got 1 1, here is the point 1 1. Then I have got 2 and 4, that's the point 2 4. So we gave values to x-axis, we got y. From both of them we got ordered pairs. We are putting those ordered pairs on the Cartesian coordinate. Connecting those points that I have got will give me what? Will give me the graph of the function. Okay, connecting them simply will give me the graph of the function. And of course, this one doesn't stop from moving. We are extending it, so that's the graph of f of x, that's equal to x squared, using plotting, because plotting is different from other things. We have got another example here, example 1 2 3. The function that is given to us is a piecewise defined function. That means on each piece of domain of the function, formula is given for the function. So between 0 and 1, from here to here, the function is defined as 2x. From 1 to 4, because it's described on x, on the domain of the function. From 1 to 4, the graph is defined as 2 over x, and from 4 onwards, the function is defined as 3. You can sketch the graph of this one by plotting, but it would be easier if you know the basic graphs of the functions. So, in general, let's sketch the graph of 2x. Okay, without mentioning the domain of this one. How is the graph of 2x? The graph of 2x is something like that. Okay, that's the graph of 2x. It's a straight line passing through the origin. The graph of 2 over x is how? The graph of 2 over x is like 1 over x, and we are sketching the graph of this one as something like that. You know this one. Okay, and it is like that. The graph of 3 is, how is it represented? It's represented as a straight line passing through 3 and intersects y-axis as 3. That's the 3 graphs together. Please, it's one function, it should be on one Cartesian coordinate. Okay, now let's come to the general graph of the function. Let us describe the function on the given domain. It says it is equal to 2x when it is between 0 and 1. So from that piece, okay, from 0 to 1, the graph is equal to 2x. How is the graph? It is that piece. Okay, it is this piece. Okay, so I will erase this part, okay, and that part of the graph of 2x. Why? Because I only needed that piece. The function is only defined 2x on that interval from 0 to 1. So I will describe the function as like that. And from 1 to 4, the graph is described as 2 over x. So from 1 to 4, how is the graph of the function? It is like that. Okay, that's from 1 to 4. Sorry, I exceed the graph of the function. Okay, so that is the graph of the function 2 over x. But which part do I need? I need the part of 2 over x from 1 to 4. So I will exclude this part of the graph, okay, and that part of the graph. Now the last part that we have got, the graph is equal to 3. That's a straight line from 4 onward. So from here to there, okay, from 4 to infinity, the graph of the function is a straight line. So I need only that piece of the function 3, and I will erase that part. So what did I get? I got the graph of the function f of x that's equal to 2 over x on that interval, and on that interval it's equal to 2 over x, I mean that one 2x, and from 4 onwards it is equal to 3. All together describes the graph of that function. Okay, here of course is an open, okay, because it's equal to 2 over x from 1 to 4. The 4 here is open because it's not included in the domain of this one, and 4 on the 3 it is included. That one is excluded, that one is included. So that is the graph of the function that is given to us. So how do we sketch the graph of a function? For now we are sketching it either using the, if you have got a basic function, if you know the basic functions, you are sketching it using your knowledge, okay, or using plotting. Now we are coming to the intercepts of graphs of functions. When we are sketching the graphs of functions, the graph of the function may intersect x-axis or y-axis or both of them. Okay, if you look at this one, it is intersecting x and y-axis at 0. If you look at this function, it is intersecting x-axis and y-axis at 0. There are no other intersection points. But the graphs of the functions that we have got may intersect x-axis, y-axis, or both of them. How do we find these intersection points? These ones are called x-intercept for those points that intersect with the x-axis, and y-intercept for those points that intersect with the y-axis. So how do we find x-intercept? We are setting, or we are putting y is equal to 0, because I have got y is equal to what? Y is equal to f of x. The function is given to me, something like that. So we put instead of y equal to 0, we will get the x-intercepts. To find the y-intercepts, we are putting every x in the function equal to 0. By doing those things, we will find the x and y intercepts of the graph of the function. We have got another way for sketching the graphs of parabolas. I mean the graphs, the functions of degree 2, where the power of the x that we have got is equal to 2. We've got 3 steps. So how do we sketch the graph of parabolas? Okay, parabola or x equal to the highest degree in the polynomial is equal to 2. We have got 3 steps. The first step, we have to check the value of a. For example, we are checking if a is greater than 0. What is a? Of course, we have got the parabola. The polynomial that we have got is equal to ax squared plus bx plus c. It is given something like this one. We are looking at that a. If a is greater than 0, then it is concaved up. Okay, that means I have got a cup shaped facing up. If that a is less than 0, that means if it is a negative number, then the function is concaved down. That means I have got a cup shape face down. The second requirement, the second thing that I will need is the intercepts. Okay, I have to find the intercepts of the function. What are the intercepts? I have to find x-intercept and y-intercept. The third thing is the vertex, the location of the vertex. The location of the vertex. What is the vertex? How do we find it? X is equal to negative b over 2a. Okay, I know the b, I know the a. I have to put those numbers into here. I will get the value of x. When I get the value of x, I'll input it into the function that we have got. We will get the value of y, and hence the vertex of the parabola. What is the vertex? The vertex is that point. Okay, that point is called the vertex of the parabola. Either if it is upward or downward, facing up or down, this point is called the vertex of the parabola. Okay, let's do the example that is given in here. It says sketch the graph of 1, 2, 4, graph f of x that's equal to negative x squared plus x plus 2. This time we will not sketch the graph of that function using plotting. What will I do? I will use that formula that way for sketching the graph of that function. How will we do that? Of course, following those steps, we will know what do we need to do. If you look at the a's, because I need a and b in the solution, a is equal to what? Is equal to negative a. It's the number that's multiplied to x squared. B is equal to what? The number that is multiplied with the x, that's equal to 1. Let's start with the solution. The first thing that I need to know is the value of a, the sign of a, if it is positive or negative. A is positive or negative here? It is negative. That means it's less than 0. So what does that mean? That means the function that I have got when I'm sketching the graph of it is concaved down. Okay, that means the shape of it is something like that. The second one, I have to find the intercepts. To find x-intercept, put y equal to 0. Okay, so what will I get? Here, 0 is equal to minus x squared plus x plus 2. Okay, I put instead of f of x 0 because I'm trying to find that value. I'll take a negative out of this one. What will I get? I'll get 0 is equal to negative x squared minus x minus 2. Okay, I'll multiply both sides by negative 1 to get rid of that negative. So what will I get? I will get 0 is equal to x squared minus x minus 2. Factorizing this one, as you have studied in college algebra, making it into two brackets, x here, x there. For 2 I have got 2 and 1. When I multiply them, I will get this one. This one is negative, this one is positive. Why? Because when I multiply negative 2 with positive 1, I will get negative 2. And when I add those two numbers, I will get negative 1 that is given in here. So here, I will get x negative 2 is equal to 0, or x plus 1 is equal to 0. Because this is the multiplication of those two. So x is equal to 2 or x is equal to negative 1. Simply you're taking this one to the other side. So what is the x-intercept? X-intercept, that means when I am sketching the graph of that function, my graph, that graph will definitely intersect x-axis at 2 and negative 1. Okay, so now I have got two things. The function is facing down the graph, and I have got the intersection points that's equal to negative 1 and 2. Okay, let's move to the third point, which is finding the vertex of the function. How do I find the vertex? The vertex x is equal to negative b over 2a. Negative b is equal to what? We found here. B is equal to 1 and a is equal to minus 1. So that will be negative 1, because b is 1 itself. I have got a negative in front of it. That will be negative 1 there. And then over 2 multiplied to negative 1. Okay? Okay, so that one is equal to what? Is equal to, that negative goes with that negative, that will be 1 over 2. So x is equal to 1 over 2. But I have to find y also, because I know that x is equal to 1 over 2, but what is the height of that x, so that I will find the real vertex of that function. So I will put 1 over 2 into the function that I have got, so that will be minus 1 over 2 squared, okay, plus 1 over 2 plus 2. That's equal to what? Equals to 1 over 4, that negative I have got here, plus 1 over 2 plus 2. Equalizing the denominators, what will I get? I'll get 9 over 4, okay, because this one is becoming 2 over 4, that one becomes 8 over 4. Equalizing the denominators and calculating the denominator will get 9 over 4. So what is the vertex of the function? Xy is equal to 1 over 2 and 9 over 4. Now I'll sketch the Cartesian coordinate. That's the Cartesian coordinate that we have got. First, let's put the intersection points, x-intercepts and y-intercepts. Oh, here we found only x-intercept, we didn't find y-intercept. What is the x-intercept? X-intercept is equal to 2 and -1. That is 2, okay, and -1. How do you find, sorry, the other side I forgot to find the y-intercept. To find y-intercept, we put x is equal to 0, so y is equal to minus 0 squared plus 0 plus 2, so y is equal to 2, okay, y is equal to 2. So here is another intersection point, that's the y-intercept. We have to also put the vertex on the Cartesian coordinate. It is 1/2 and 9/4. 1/2 is here, 9/4 is nearly half, okay. So that is the vertex of the function, although the points are not so clear and nice, but that's the best I could do for you. Now connecting those points, okay. Sorry, that point, let it be here, okay. Those points, I'm connecting them. Why did I make the parabola upside down? Because I know that the value of the a that I have got is negative and the parabola is upside down. This is the vertex of the parabola. It is intersecting y-axis at 2, okay, and it is intersecting x-axis at -1 and 2. So that is the graph of the function of the parabola. So we can sketch the graph. Of course, when I ask you to sketch the graph of a parabola, I will require it from you using those steps, not by plotting them, okay? I will not require this way. I want you to sketch the graph of the function using that way. Now we are coming to intersections of graphs, okay? Intersections of graphs. What's the difference between this one and the intercepts? When we were talking about intercepts previously on here, we were talking about x-intercept and y-intercept. The function that I had only one function, and it was intersecting. We were finding the intersection point of that function with x-axis and y-axis, x-intercept and y-intercept. But when we are talking about intersections of graphs, here I have got two functions or more functions to have intersection points together. But here in generally, you have got only two functions. So I have got the function f of x, okay, and I have got another function g of x. If I sketch those two graphs together on one Cartesian coordinate, they may have intersection points. They may have. I don't say that every time they have got intersection points. It is sometimes possible to find their intersection points, and sometimes it is not possible. That means they have got no intersection points. For example, if I have got that one, okay, I have got the graph of a function like this one, and I have got another function like that. This, for example, that one is g of x and that one is f of x. If you look at those two functions, they are sketched on the same Cartesian coordinate. This one, and that point are their intersection points. So these ones are intersections of graphs. How do I find those points? I simply equalize f of x with g of x. Okay, f of x is equal to g of x. So if it is required from you to find the intersection point of two graphs of functions, you simply equalize them to each other. Solving them, you will get those intersection points. It is so simple. You have studied this one in college algebra. Okay. The first example that we have got about intersections of graphs of functions is example 1.2.5. It says find all points of intersection. Find all points of intersection of f of x of graph of f of x that's equal to 3x plus 2, and g of x is equal to x squared. So what do I have here? I have got f of x is equal to 3x. In the book it's given as 3x plus 2, but I change it to negative 2 because if I put plus 2 here, later on I will need a quadratic formula. I do not want you to use quadratic formula. Simply using brackets, it will be easier. And it is required from us to find the intersection points of those two functions. Since intersection points are required from us, so we simply equalize them to each other. F of x equal to g of x. So 3x minus 2 is equal to x squared. That's easily solved. Okay, we are taking those ones to the other side, so that will be x squared minus 3x plus 2. And then 0 is equal to what? 0 is equal to those two brackets, x here, x there, to get the x squared, 2 here, 1 there, to get the 2. Both of them are negative because when I multiply them I will get positive 2, and when I add this one with that one I will get negative 3. So in general, x is equal to what? X is equal to 1 or x is equal to 2. So when I sketch the graph of this function with that function on the Cartesian coordinate, how will their intersection points be? It will be, they will intersect at x equal to 1 and x equal to 2. Okay, so here is the graph of x squared, that graph, and the graph of 3x minus 2. They intersect as x at x equal to 1 and x equal to 2, and that's their intersection points.